Hello guys, welcome back to Dharma Geosphere. Thanks a ton for all the good response and the clarifications you have sought for my earlier videos. Today I have come up with another very important topic in geomorphology, that is about the erosion surfaces. So we will try to understand what is erosion surface, and then I'll go on to tell you the various types of erosion surfaces, which is perhaps the most important or the core element of the erosion surfaces. But before we go on, I'll try to explain what is erosion. Basically, you should understand erosion is basically wearing and tearing away of rock materials and then carrying it away to far off regions and through the process of transportation. So if both the erosion and transportation occur together, that is the overall process of erosion. But if it is only chemical or mechanical breakdown, wear and tear of the rock material, it just is weathering. So in erosion, it's a more complex and a very long-term process involving both the wear and tear of the rock material as well as transportation through various agents like water, wind, glaciers, groundwater, coastal lands, etc. So basically erosional surface is kind of a flat land surface which cuts through the underlying geological formations and not through any structural means by say like faulting or through folding or any other structural process. So the erosional surface can be formed in various ways, in various environments, depending on the various factors. So the erosional surface is quite different from any of those elements which are formed due to the structural movements or say even by tectonic processes. The fine example of the erosion surface is the Ranchi Plateau, which has been eroded during the Jurassic time and was later flooded by basaltic lava during the Cretaceous and was finally uplifted during the tertiary time, and wherein it formed these patland like mesas and buttes. So such a low gradient landform is just not an exposed geological surface, but is the testimony of the various geomorphic processes that it has undergone during the historical evolution of such a landform in this wider landscape. So study of the erosion surfaces is very important to understand the various geomorphic processes that have undertaken over a period of time. Not only that, erosion surfaces also bring in a lot of important information related to the mineral deposits and the metallic deposits that are occurring today and how they came to be forming the present day as we see today. The erosional surface, if you see that in a stratigraphic column, that is generally called an unconformity, where it divides rocks of different ages. But not all buried unconformities are erosional surfaces. So guys, I have broadly divided the presentation into a few subtopics. We will start with the introduction, then we will understand what are the myths about erosion surfaces, and we will also try to differentiate between an erosion surface and other planar surfaces formed due to erosion. What makes erosion surface a very distinctive landform larger landscape, and then we will understand the types. Here is where I find that the students get little confused in seeing most of these what the so-called mentors or who teach geography or who are not from geography background do not understand the geomorphic scales, and they mix up between the erosion surfaces occurring in the landscape scale and the landform scale, which are totally different. Here I'll try to distinguish what are the erosion surfaces in the landscape scale and also in the landform scale. And then we'll see what are the various factors which are involved in the formation of the erosion surfaces, and we will also see the methods of identification of the erosion surfaces, and also see how they get modified, what are the factors which influence their modification over time. And then we will also see a case study of how erosional surface has evolved, and we will see how also the dating of the erosion surfaces can be done, and what are the constraints and what are the issues involved, and finally we will also understand what are the problems in the identification of erosion surfaces. So this is the framework of the today's presentation. We will introduce the subject on the erosion surfaces, what is erosion surface and how it is different from the other surfaces. There are some myths about erosion surfaces which students get confused. I'll try to resolve those issues. And then we'll also understand the difference between an erosion surface and the other surfaces, planar surfaces and structural surfaces caused by the process of erosion. And then we'll understand what are the factors for development of erosion surfaces, and we'll see types of erosion surfaces is an important aspect of the erosion surfaces. And then we'll also see the identification of erosion surfaces, and we'll see how they get modified, and then we'll see what are the problems, though I discussed this in my earlier video. And then we'll also understand the dating of erosion surfaces, and finally a case study of erosion surface in India apart from the Ranchi Plateau, which we take as an example. So always in your answer, try to give an international example, an Indian example, and one case study either from international or from India, preferably from India. So as I've said, this is the erosion process which involves both the weathering and transportation, and the Ranchi Plateau is an example of an erosion surface, one of the classic examples of erosion surface because of a very prolonged erosional process that has taken place and recorded and documented in our country. The erosion surfaces are quite important. So this is the Joda Pahad erosion surface, which is in Selberg. This is another example of Montague Beach erosion surfaces. So myths about the erosion surface. A lot of students get confused because it is repeatedly said in various mentor shops that the erosion surfaces occur at the sea level. That is not so. Contrary to this oversimplification of the Daviesian doctrine of the erosion cycle, the erosion surfaces may form at least locally at a varieties of elevations above sea level, providing raised base levels, and it can therefore not always be ruled out that the scattered local erosion surfaces in a mountain range were formed locally and quite independently of one another instead of representing a single regional erosional plain that has been subsequently dissected and fragmented by faulting. So erosional surfaces can form both at below sea levels and also more prominently at the above sea levels. So if you can see here, this is the one which is formed during relatively fall of the sea level, and then here you can see the erosion surface which has been formed relatively above the sea level due to the sea level rise. The other myth is that the erosional surfaces are horizontal. As you can see, most of the erosion surfaces are in fact sloping. This is the Pyrenean classic example of an erosion surface which is sloping. And that the eroded surface are removed away and gone forever, but that is not true. In fact, they actually get relocated and recycled, just like the rock cycle, the erosion cycle, and the erosion surfaces come back to the surface of the earth and then again start getting uplifted and further getting eroded. So you should remember that the eroded surface are not removed away. It's a different thing that they may get buried or they may get relocated, but then they remain in the earth system. So, and then there's another belief that most of the definitions I have seen in the some of the Indian books and also these coaching institutions, that they only deal with the erosion surfaces on the land, but it is not true. Erosion surfaces also occur in the oceans. Erosion occurs in the ocean and therefore the erosion surface. So here is an example of a close-up of a rock erosion surface very close to the coast. In fact, the entire coastal erosion creates these erosion surfaces within near the beach and also within the continental shelf. Coming to another very important thing is the difference between erosional surface and the other erosional surface. Yes, the erosional surfaces or planar features or horizontal structures are also created due to structural mechanism, folds, faults, or maybe due to unconformity. It could be jointing, it could be tectonic movements. So here we try to differentiate between an erosion surface and a structural bench, which in the field look more or less like the same. But whereas structural benches in topography are shaped by differences in rock resistance and are therefore essentially an expression of rock mechanics, that is structural element, erosion surfaces cut across all the rocks of varying resistance. It could be hard rock or it could be soft rock. As I said in the definition, they indiscriminately cut across the geological structure irrespective of it is resistant rock or non-resistant rock. That kind of a power they have in the erosion because of the erosional force, and they also cut through the dips and structures of the structural topography in there. So you can see here how the landforms in horizontal regions like table mountains, structural benches are cut across. Then the structural surfaces which are basically generated by process interacting with the resistances imposed by rocks and sediments. Generally the structural surfaces, the weak rocks are eroded, whereas in erosion surface, irrespective of whether it is weak or resistant or hard or soft, they get eroded. So the erosion surfaces are formed due to both hard and soft rocks and different geological structures like fold, fault, etc. Coming to factors responsible for the development of erosional surfaces, there are three prominent factors. There could be other which can be associated with these. One is the agent of denudation, then depending on which kind of denudation and during which period it is. Say fluvial during probably after the Mesozoic and before tertiary, the fluvial activity was much more greater because of the glacial periods and interglacial period. During the glacial period there will be a lot of melting glaciers melt, and then the water comes and then they form into rivers, and therefore the erosion rate is much higher. So during those times the erosional surfaces formed were much more and well preserved rather than those which formed before the Mesozoic, wherein a lot of dissection has happened and the rock structure was not favorable for formation of the erosional surfaces. And then the climatic factor, if there is rain, torrential rain, you can see totally different kind of a landscape with a different erosional surface, and also the climate change can also bring in a factor, and particularly say during glaciation where glaciers are formed, the frost action really effectively conducts the erosion, and you find different kinds of landforms finally resulting in moraines and the erosion surfaces. Similarly, tectonic activity, where there is subsidence and uplift, wherever there is uplift, the erosion is much more, we have seen. We can recall that the deviation cycle of erosion has said that whenever there is uplift, there is a thorough and a very effective erosion. So if you can see the various agents of denudation, fluvial, glacial, wind and etc. They have formed various types of erosional surfaces. Say, for example, peneplained is a result of fluvial processes, whereas periglacial erosion surface is that caused due to the glacial agent. Then the climatic factor, you can see very schematically shown here. During the Pleistocene age, the areas engulfed by glacier underwent glacial erosion rather than fluvial. So glacial is much more effective than fluvial. So effective erosion also created a lot of landforms, including the types like the glacial moraines and valley floors, etc. And then the tectonic activity may impact normal cycle because the emergence and submergence of surface due to the endogenic forces before completion of the cycle of erosion will result in mountain building. Mountain building will also can result in uplift and subsidence, which can effectively involve the erosion. So this is broadly a tectonic activity. This kind of a diagram, if you read, it captures that the tectonics, crustal thickening, isostic uplift, deformation, and erosion includes fluvial incision, mass wasting. Mass wasting is on gravity and this glacial interaction. So tectonics plays a very important role in finally developing the peneplained surface, depending on what kind of a rock structure it is and what kind of climatic factors are there and the denudation rates as well. So 5 types of erosional surfaces. Please be very clear and do not get confused between a landscape feature and a landform scale. I'll show you what is the basic difference between what a landscape is and what a landform within the landscape is. So the landscape erosional surfaces include badlands, canyon lands, plains, there are remnant features, say for example valley floors, and you also have remnant eroded fans, and then you also have, when you come to landform scale erosional surfaces, they include peneplains, inselbergs, monadnocks, knobs, knolls, stacks, butties, cols, gaps, and saddles. Please try to remember this, and though a question has come on the erosion surfaces in last time, it doesn't mean that it will not repeat. Anyway, as far as my mentorship goes, I will cover all the topics and I expect students to cover all the topics. That will take you a lot of confidence when you go to the exam hall and just take up the paper and challenge it. Okay, so there could be a question on types of erosion surfaces. So landscape and landform, please be very clear. Many of those who have been interacting with me, students, they get confused here because nobody has taught, because non-geography students are all over the place trying to involve in teaching of geography. But please be informed and please make it very clear to yourself that landscape is a naturally formed feature on the Earth's surface having a characteristic shape or form, and it is the size of a country. Okay, so you have the Appalachian Mountains or the Alps like this. So that is a landscape. So within that landscape, a visible feature of an area including both natural mountains and forests and rivers, and also man-made anthropogenic landforms that exist within the landscape. So this is the difference. So the erosional surfaces, the slope development, the denudation in chronology, they all occur both at the scale of landscape as well as landforms. So this you distinguish, get a lot of stuff to write about. You can see beautiful pictures, beautiful diagrams you can draw, and then make your answer very impressive. So the landscape scale erosional species is a badlands and canyon lands. You have the spires of sandstone, as you can see here, a part of a huge landscape. And then you have valley floors. The erosional fan remnants is another very important feature of the landscape scale. And then the landform scale erosion surfaces include the peneplains, the inselberg, monadnocks, knobs, knolls, stacks, buttes, cols, gaps, and saddles. So all these are the landform scale erosion surfaces, different types of erosion surfaces. You can see this is the gap, this is saddle, this is a knob, this is a knoll, this is a peneplain, this is a butte, this is a photos of the uplifted peneplain in western Greenland. This is Monadnock. Then this is an Inselberg. This is a stag. This is a call. Then coming to the identification of erosion surfaces. Regarding the identification of erosion surfaces, there are different methods. You can do through the drainage analysis from a topographic sheet, and then overlap the profiles and can identify where the erosional surface has occurred. You can also do it through the age correlation method, the sampled area of the erosion surface with the known age of the area, and then also area height diagrams, the way it has been done in the Ranchi Plateau. Then superimpose profiles through drainage basin mapping, and also through geological unconformities, where you can see near the unconformity divides to different lithologies of different age. So from that you can predict where the erosion surface occurs. And then there are more modern methods where you combine the geomorphological identification, as I have said, through radiometric methods, and also through satellite and laser scanning and repeat photogeological photography. Then you can combine these and then easily identify the erosion surface. So they can be divided into direct and contact measurement methods, where you use what in geology are called as erosion meters. That is, directly you can measure the rock surface from the various sediments and identify whether it is formed due to the structural forces or through the long drawn erosion process, which will lead to the erosion surface. So non-contact methods and indirect measurements as well can be combined with the direct measurements and the geomorphological studies, that is through laser scanning and also repeat photography and digital photogrammetry. And you can also use cosmogenic dating, where particularly the landforms, or where the land surface consists of a lot of organic matter. So this is the profile which from where you can deduce the and identify the erosion surface, and you can also use this profile data and just use the topographic view and then find out where the erosion surface is. Similarly, these are superimposed adjusted profiles, say for example in the Dalung River Basin, where they have identified an erosion surface, superimposing the adjusted profiles of the river systems. This is the steady area where in the Arun River profile they have identified the maximum elevation and the mean elevation and the major nick points, where there is a flat surface that was seen somewhere here, and that is identified as an erosion surface. Then modification, it depends. Factors mainly are the age of the surface, it could also be thickness, and what is deposited on them, and the rock resistance. I'll show you the examples. So the older this erosion surface, the greater is the modification of the erosion surface through several factors, including environmental factors. Say for example, if you take the Waipanamo erosion surface, an important feature in the East Otago, where it helps to form a low relief topographic surface that is visible in most of the mapped area. The erosion surface that developed as the Otago region progressively sank and the sea got encroached over a long time. I'll show you how after the Cretaceous and through the Oligocene period, it has the age of the erosion surface became progressively younger inland, as you can see, and then finally formed the what is called as the gold deposits here. So you can see the three ages, how the erosion surface evolved over time and finally led to the formation of the well-known alluvial gold mine. Similarly, the thickness affects the erosion surface. The thicker it is, the more the modification, because it has so much of uplift and sediments which can get eroded, and finally the entire erosion surface gets modified. Sometimes a remnant of that remains to identify it as a erosion surface, and you can see over the years the thickness has actually affected the erosion surface over years. Then the rock resistance, I have shown the resistant rocks are those which are hard igneous rocks. Igneous means that is coming from fire. They are very hard rocks, very resistant rocks like granite, basalt, and they are very resistant to erosion. So they make huge granite cliffs, unlike the clay and shale, which are weak sedimentary rocks. They make small boulder cliff plays, as you can see the difference. And then obviously weak rocks are peneplained and modified faster in a shorter period of time, but resistant rocks like granite and basalt take a much longer time and complete the cycle of erosion, as the denudation rates are very slow because the rock is very resistant to erosion. It takes a number of years to get eroded. So here is the compared the hard rock and the soft rock, how they get eroded over time and how eventually the erosion surfaces form in these rocks. The problems of erosion surfaces, I have already discussed this with you, particularly before Mesozoic, the lithologies were variously denuded and almost impossible to identify because of very highly dissected surfaces. And then but later tertiary and pre-quaternary were the younger surfaces formed on the resistant surfaces, and they formed extensive plateaus and unimaginable, unrealistic heights they reached and formed preserved erosion surfaces. Then dating of erosion surfaces. The dating is very important for the erosion surfaces to first identify it as an erosion surface, and also to understand the evolution of the landform in that particular region for doing various plans and maps for developmental activities. The dating of erosion surface is critical to understanding landscape evolution. Not only reliable dating results with acceptable precision and accuracy, it is hard to find a suitable dating material, and it also is quite difficult. See, organic or sedimentary rocks do not have such dating materials as that can be found in igneous rocks like the zircons and all that, which are preserved very old ages. Then the radiocarbon dating, of course, can date the erosion surfaces, but not beyond 40 K. K is kilo N, or that is 1,000 years. That the range of, then you also have thermoluminescence and infrared simulated luminance, which can date the erosion surfaces from natural sediments, and this extends up to 120 K. And then one of the best and well proven one is the electron spin resonance. It offers the possibility to extend the time range of sediments even up to 1 million years and beyond. Then once you have given the example of Ranchi, you can take the case study of Sangra, where erosion determination of erosion surfaces and stages of evolution was very systematically done in the Sangra drainage basin in the Girit district in Jharkhand. To analyze this work, functional theory has been used, and it was also supported and supplemented by quantitative approaches of geomorphology. So this is a very important study. So this, you can use it as a case study for the erosion surfaces. So that's all, guys. We have covered almost everything what is required in the erosion surfaces. Just make your own points from the PPT, and just stay focused, study well. I'll keep bringing you all the important topics, and we will try to complete it before March, so that you take the prelims exam, and then you're ready to go cracking on the geography optional. So once again, thanks a lot for all the good response, and I'll continue to bring various important topics in geomorphology and entire geography optional, and we'll try to cover as quickly as possible. So thanks a lot guys again, and bye.